Welcome all of you. Welcome to today's class of Pharmaceutical Organic Chemistry. I am Rosalind Mishra, Assistant Professor, ITS College of Pharmacy. I shall be dealing with today's topic of aliphatic amines. Okay. So, now since our previous classes we were discussing on topics related to unit 5. Okay. So, your unit 5 of Pharmaceutical Organic Chemistry is composed of two major heads, which is carboxylic acid and aliphatic amines. Under carboxylic acid, we were dealing with acidity of carboxylic acids, effect of substituents on acidity of carboxylic acids. We had learnt about the inductive effect and qualitative tests for carboxylic acids. We have even learnt about amides and esters chemical tests. Okay. Then we had learned about structure and uses of various derivatives of carboxylic acids, namely acetic acid, lactic acid, tartaric acid, citric acid, succinic acid, oxalic acids, salicylic acids, benzoic acids, benzyl benzoates, dimethyl phthalates, methyl salicylates and acetyl salicylic acids. Okay. After that, we have moved on towards aliphatic amines. Under aliphatic amines, we have discussed in detail about basicity of aliphatic amines, effect of substituents on the basicity of aliphatic amines, qualitative tests of aliphatic amines, structures and uses of ethanolamine, ethylenediamine and amphetamines. Okay. So, in today's class we will be dealing with a few properties of amines. Talking about the chemical reactions of amines, as we have already talked about it, amines are similar in reaction to ammonia. Okay. So, the whatever reaction they give, it is similar to ammonia. Like ammonia, amines are basic in nature. Like ammonia, amines are nucleophilic. They react with alkyl halides, acid chlorides and carbonyl compounds. Okay. Just like ammonia, amines also react with alkyl halides, acid chlorides and carbonyl compounds. The aromatic amines are highly reactive in nature. They show electrophilic aromatic substitution reactions. Okay. So, with this we move on further towards the chemical applicability of amines. Now, synthesis of nylon is one of the most important uses of amines. Okay. Nylons, what are these nylons? Nylons are condensation copolymers. Okay. These are condensed polymers formed by reacting equal parts of a diamine and a dicarboxylic acid. When equal parts of dicarboxylic acid is made to react with a diamine. Okay. When a dicarboxylic acid is made to react with a diamine, so that the peptide bond forms at both ends of each monomer. A peptide bond is formed, C double bond O, NH bond is formed at the ends of both monomer in a process analogous to general reaction as we have shown. Okay. So, how is a nylon formed? Basically, nylon is a copolymer. Okay. It contains n number of repetitive units of amines and carboxylic acids. Amine in the form of diamine, carboxylic acid in the form of dicarboxylic acid. They are attached to each other in such a manner that peptide bonds are formed on both the groups. Okay. So, here we take a dicarboxylic acid and make it to react with the diamine. So, a C double bond O NH bond is formed on both the ends of the diamine and the dicarboxylic acid. So, n number of these or the chain of this dicarboxylic acid and diamine makes up nylon. So, what are nylons? They are condensation copolymer formed by reacting equal parts of a diamine and a dicarboxylic acid, so that the peptide bond formed at both ends of each monomer in a process which is analogous to polypeptide biopolymers. Let us learn a few basic concepts of nylon production. The first approach which is taken here is combining molecules with an acid group. Okay. Molecule having an acid group is combined on each end and are reacted with two chemicals that contain amine groups on each ends. Okay. So, a nylon is made up of hexamethylene diamine with 6 carbon atoms and a acidic acid as well containing 6 carbon atoms. The second approach could be a compound has an acid at one end and an amine at the other end. Okay. They are polymerized to form a chain with repeating unit of NH CH2 n times COX. Okay. NH CH twice n times CO C double bond O X. They form nylon. They are made from a single 6 carbon substance called caprolactam. Okay, they are formed from single 6 carbon complex known as caprolactam. So, basic concept for the nylon production is obtained or achieved by two approaches. The first approach is combining molecule with an acid group on each and are reacted with two chemicals that contain amine group on each end. Okay. They form nylon made up of hexamethylene diamine with 6 carbon atoms and acidic acid as well as having 6 carbon atoms. The second approach is a compound has an acid at one end and an amine at the other end and is polymerized to form a chain with repeating units. Apart from producing nylon, amines are also used for synthesizing dyes. They are used for synthesizing dyes. Okay. For example, yellow azo dye. For example, yellow azo dye. This azo dye is produced by coupling of amines. Okay. Primary aromatic amines are used as a starting material for the manufacturing of azo dyes. So, primary aromatic amines, generally aromatic amines, are used for making large number of azo dyes. Azo compounds, what are these azo dyes or what are these azo compounds? Well, azo compounds bear the functional group R double bond R N double bond N R dash. Okay. So, this is the general formula for an azo dye, where R can either be an aryl group or an alkyl group. The N double bond N group is called as azo group. Okay. NH group is also called as diimides. Aryl azo compounds have vivid colors. Okay. The most important use of these aryl or azo dyes are they have got vivid wide range of colors, especially red, orange and yellows. Hence, they find use in a lot of industry, right from coloring agent to the textile industries. Okay. They are used as coloring agent in a number of pharmaceutical preparations till textile industry. They find use in a wide range of places. So, what happens is these amines are used for the synthesis of dyes. What are dyes? Well, primary aromatic amines are used as a starting material for the manufacturing of azo dyes. Okay. So, what are these azo dyes? They either contain azo group, which is N double bond N group, or they contain diimides. Okay. Aryl azo compounds, the primary use is due to their coloring effect. They have got vivid colors ranging from red, orange and yellows. Amines, how are these azo compounds formed? Well, amines react with nitric acid to form diazonium salt. Alright, what happens is amines react with nitric acid to form diazonium salt, which can undergo coupling reaction to form azo compounds. The diazonium salt, namely N double bond N plus Cl minus, this diazonium salt can undergo coupling reaction to form the azo compounds. Azo compounds are highly colored. They are widely used in dyeing industry. Okay. They have colors such as methyl orange, direct brown 138, sunset yellow and ponchu color. These are just examples of few of the shades of the azo dyes which has been described. So, what here you can see a wide range of colors which the azo dye shows, starting from red, yellow, violet, orange, etc. Methyl orange is one of the common azo dyes. See, we know very well that these azo dyes are used in textile industry, but apart from that, azo dyes also find a huge importance, or they find a varying use in pharmaceutical industry also, either as indicator or as coloring agents. Okay. So, for example, methyl orange is used as an acid base indicator. It is due to the different color which it produces in acid and salt forms. Okay. It is also known as artist's paints. Okay. That is clays yellow to red range dye in food and textile. Azo dyes are also known as acids paint, which is used, artist's paint, which is used in claying, in which are mixed with clay to color them. The yellow to red range dye is used in food and textile industry. Okay. So, now here we have described the structure and we have named few of the azo dyes. Okay. These are the examples of the azo dyes which are safe to use and are used in food industry. Number 1, tartrazine. Number 1, tartrazine. This is the azo chain. Okay. So, the diazonium salt forms coupling reaction to form tartrazine. Similarly, yellow 2G is another shade of azo dye, is another type of azo dye. Sunset yellow is the third type of azo dye. Okay. The next one is azorubin, wherein the diaza compound forms coupling or forms a couple with another aromatic group to form azorubin. Okay. So, these are the few examples of azo dyes which are used in food industry, starting from tartrazine, yellow 2G, sunset yellow, azorubins, etc. Apart from this, there are other azo dyes as well. For example, amaranth. Amaranth is an azo dye which is used in food industry. Ponchu 4R. The diaza group is common in all these compounds. It is common in all the above compounds. Okay. So, amaranth, ponchu 4R, allura red, brilliant black, these are the other azo dyes which find their use in food industry and textile industry, etc. So, the two major uses of azo group, that is synthesis of nylon, namely industrial uses, okay, synthesis of nylon and synthesis of dye are of utmost importance. These dyes not only are industrially applicable, but are also used as coloring agents in food industry and in coloring of several pharmaceutical syrups and other pharmaceutical preparations also. they have got chemical importance in the form of indicator, because under acidic condition they show a certain color and they change this, or they tend to change their color under basic condition. Okay. So, this nature of the azo dye is used in making up of indicators, for example, methyl orange indicator. Alright. So, with this we move on further towards discussing various derivatives of amines and their structure and their uses. Okay. So, the first type of amine or ethanolamine. Okay. Ethanolamine. Ethanolamine, also known as 2-amino-ethanol or also known as monoethanolamine, is an organic chemical compound having a molecular formula OH CH2 CH2 NH2 or OH CH2 twice NH2. Okay. So, this is the general formula for ethanolamine. The molecule is both primary amine and a primary alcohol. Okay. Ethanolamine is not only a primary amine, it is not only a primary amine, but also a primary alcohol due to the presence of OH group attached to the alkyl substituent. The preferred IUPAC name of ethanolamine is, it is also known as 2-amino-ethan-1-ol. Okay. So, ethanolamine is also known as 2-amino-ethan-1-ol. The other names of ethanolamines are 2-amino-ethanol, 2-amino-1-ethanol, beta-amino-ethanol, beta-hydroxy-ethylamine and glycerol. Okay. So, ethanolamine has got a number of common names, for example, 2-amino-ethanol, 2-amino-1-ethanol, beta-amino-ethanol, beta-hydroxy-ethylamine and glycerol. Glycinol. The chemical formula of ethanolamine is C2H7NO. It has got a molecular mass of 61.08 gram per mole. The appearance, if we talk about, then ethanolamines are viscous, colorless liquids. Ethanolamines are viscous, colorless liquids. They have got an unpleasant odor which is similar to ammonia. Due to the presence of the amine attached, they have got an unpleasant ammonia like odor. The density of ethanolamine is 1.0117 gram per centimeter cube. The boiling point of ethanolamine is 170 degrees Celsius and ethanolamines are miscible in water. Okay. If we talk about the solubility in water, ethanolamines are water miscible compounds. Moving on towards discussing the applications of ethanolamine. Ethanolamine is used as a feedstock in the production of detergents, emulsifiers, polishes, various pharmaceuticals. They are used as corrosion inhibitors, they are used as chemical intermediates as well. Okay. So, ethanolamine has got a wide range of uses under industrial application, that is, they are used as feedstocks for the production of detergents, they are used as emulsifiers, they are used as polishes, they are used as corrosion inhibitors, they are used as various chemical intermediates as well. Ethanolamine is used as a very important pH regulator in cosmetic industry. It is often used for alkalinization of water in steam cycles of power plants, including nuclear power plant with pressurized water reactors. Ethanolamine oleate is used to treat esophageal varices. Esophageal varices is a condition in which dilated blood vessels inside the tissue lining, the esophagus or upper part of the stomach happens. So, pharmaceutical application of ethanolamine include treatment of esophageal varices. Next, the next important amine derivative is ethylene diamine. Ethylene diamine is the organic compound with the formula C2H4NH2 twice. Okay. So, this consists of two alkyl group, which is ethylene, and a diamino group, ethylene diamine. Okay. So, ethylene diamine is widely used building block in chemical synthesis. Ethylene diamine readily reacts with moisture in humid air to produce a corrosive, toxic, irritating mist, to which even short exposure can cause serious damage to health. Ethylene diamine is the first member of the so called polyethylenamines. The IUPAC name of ethylene diamine is ethane 1,2-diamine. It is also known as edamine 1,2-diaminoethanes. Ethylene diamine has got a chemical formula of C2H8N2. It has got a molar mass of 60.10 gram per mole. It is generally colorless liquid. The odor is ammonia like. Okay. Ethylene diamine has an ammonia like odor. The density of ethylene diamine is 0.9 gram per centimeter cube. The boiling point of ethylene diamine is 116 degrees Celsius. When we talk about its miscibility in water, then they are water miscible compounds. Ethylene diamines are easily water miscible. Okay. Speaking about the applications of ethylene diamine is a most prominent derivative of ethylene diamine tetraacetic acid. Okay. Ethylene diamine is a most important component of EDTA. EDTA is a chelating agent, ethylene diamine tetraacetic acid. Ethylene diamine is an ingredient in the common bronchodilator drug aminophylline. Okay. So, though ethylene diamine is toxic when subjected to atmospheric moisture, still ethylene diamine has got a wide range of pharmaceutical and chemical importance. Number one, it is used for making up the chelating agent, which is ethylene diamine tetraacetic acid. Apart from this, it is also used in making up the common bronchodilator, which is aminophylline. It is a drug aminophylline, where it serves to solubilize the active ingredient theophylline. Ethylene diamine also has been used in dermatologic preparations. So, apart from being used as a bronchodilator, it is used in dermatologic preparations as well. It has been used as urinary acidifier. Ethylene diamine has found its use as an urinary acidifier. It is also used for the synthesis of first generation antihistamine drug piperoxan. Okay. So, we can see very well how ethylene diamine has got a wide range of pharmaceutical importance, right from being used as a bronchodilator to being used as urinary acidifier to being used as a common or first generation antihistaminic drug. Ethylene diamine, because it contains two amine group, is a widely used precursor to various polymers. Okay. Condensate derivatives from formaldehydes are plasticizers. When it undergoes condensation with formaldehyde, they are used as plasticizers. It is widely used, also widely used in the production of polyurethane fibers. Ethylene diamine is also used as a corrosion inhibitor in paints and coolants. Okay. So, with this we have discussed about various pharmaceutical uses of ethylene diamine. Moving on to amphetamine. Amphetamine is a potent central nervous system stimulant that is used in the treatment of attenuation of deficit of attention deficit hyperactivity disorder, a disorder known as ADHD. Okay. It was discovered in 1887 and exists as enantiomeric form, dextroamphetamine and levoamphetamine. Here we have briefed about the appearance, odor, density and boiling points of amphetamine. It is also known as 1-phenylpropan-2-amine. Applications involves treatment of attention deficit hyperactivity disorder. It is used in narcolepsy. Amphetamine is used by some athletes for its psychological and athletic performance enhancing ability. At therapeutic doses, amphetamine causes emotional and cognitive effects such as euphoric effect. With this, we finish up our topics. These are the references. Thank you for watching. I am sure all of the topics which we have covered in our unit 5 comes of utmost importance and use to you all. Please watch it carefully, listen to them carefully. Thanks for watching. Stay healthy, stay safe. Thank you.